Section 08. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about transfer learning with TensorFlow. This section is focused on the powerful technique of transfer learning, where you leverage pre-trained models to solve new tasks with less data and training time. Here's what you'll find in this section. Article. We begin with an in-depth article discussing transfer learning with TensorFlow. This article covers key concepts and examples to help you understand how to apply transfer learning effectively. If you have any questions or need clarification on any part of the article, please feel free to message me directly. Assignment. Topic: Fine-tune a pre-trained model for your dataset. Details. This assignment will guide you through the process of fine-tuning a pre-trained model for a specific dataset. The instructions are detailed, with solution hints provided to assist you. Once you complete the assignment, you can submit it to me for feedback. Coding exercises. Load a pre-trained model, example VGG16, Inception. Learn how to load and utilize pre-trained models like VGG16 or Inception in TensorFlow. Freeze layers and add custom layers for your task. Understand how to freeze the layers of a pre-trained model and add custom layers tailored to your specific task. Prepare data for transfer learning. Get hands-on experience in preparing your data for transfer learning. Train the model on your dataset. Practice training the fine-tuned model on your dataset. Evaluate the performance of the fine-tuned model. Learn how to evaluate the model's performance after fine-tuning. Compare results with and without transfer learning. Analyze and compare the results achieved with transfer learning against training from scratch. You can watch the accompanying video where I walk you through these coding exercises, including their solutions, algorithms, and the skills required to complete them. After completing this section, you will be able to understand and apply transfer learning using TensorFlow. Load and fine-tune pre-trained models for custom tasks. Prepare datasets specifically for transfer learning applications. Evaluate and improve the performance of fine-tuned models. Compare the effectiveness of transfer learning versus traditional training methods. If you have any questions, confusion, or encounter any problems, please don't hesitate to message me. I'm here to help you succeed. Section 08. Problem 01. Problem statement. Load a pre-trained model from TensorFlow's model library to leverage its learned features for a new task. Skills required: understanding of transfer learning and pre-trained models. Instructions. Import TensorFlow and load the pre-trained model. Remove the top classification layer for customization. Algorithm. Import the model from TensorFlow's library. Remove the top layer of the model. How code is working. The code loads the VGG16 model with weights trained on ImageNet and excludes the top classification layer to customize it for a new task. Problem 02. Problem statement. Modify the pre-trained model by freezing its layers and adding custom layers for specific classification tasks. Skills required: model modification and customization. Instructions. Freeze the layers of the pre-trained model. Add custom layers on top of the base model. Algorithm. Set trainable property of base model layers to false. Add custom dense and dropout layers. How code is working. The pre-trained layers are frozen to retain learned features, while new layers are added for the specific classification task. A new model is created with these modifications. Problem 03. Problem statement. Pre-process and prepare your dataset to match the input requirements of the pre-trained model. Skills required: data pre-processing and augmentation. Instructions. Load and pre-process your dataset. Apply transformations such as resizing and normalization. Algorithm. Load dataset using TensorFlow or Keras utilities. Apply pre-processing steps and data augmentation. How code is working. The code sets up data augmentation for the training data and rescaling for the test data. It loads images from directories and formats them for training and evaluation. Problem 04. Problem statement. Train the modified model on your dataset using the prepared data. Skills required: model training and hyperparameter tuning. Instructions. Compile the model with the loss function and optimizer. Train the model using the data generators. Algorithm. Compile the model with a suitable loss function and optimizer. Fit the model to the training data. How code is working: the model is compiled with the atom optimizer and categorical cross-entropy loss. It is then trained on the training data and validated using the test data. Problem 05. Problem statement. Evaluate the performance of the fine-tuned model on the test dataset. Skills required: model evaluation and metrics analysis. Instructions. Evaluate the model on the test data. Output the evaluation metrics. Algorithm. Use the model's evaluate method on test data. Print the results. How code is working: the model's performance is assessed on the test dataset, providing metrics such as loss and accuracy. Problem 06. Problem statement. Compare the performance of the transfer learning model with a model trained from scratch. Skills required: comparison and analysis of model performance. Instructions. Train a baseline model from scratch. Compare its performance to the transfer learning model. Algorithm. Define and train a baseline model without pre-trained weights. Compare the accuracy and loss metrics of both models. How code is working: a baseline model is trained from scratch, and its performance is compared to the transfer learning model. Metrics such as accuracy are compared to evaluate the benefits of transfer learning. Section 09. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about TensorFlow with Keras API. This section is designed to give you a solid foundation in using TensorFlow alongside the Keras API, making it easier to build and train deep learning models. Here's what you'll find in this section. Article. The section starts with an article discussing TensorFlow with Keras API. This article covers the core concepts and provides examples to help you understand how to effectively use Keras with TensorFlow. If you have any questions or need clarification on any part of the article, please feel free to message me directly. Assignment. Topic: build and train a model using Keras. Details. In this assignment, you will learn how to build and train a model using the Keras API. The assignment includes detailed instructions on how to approach the task, solution hints to guide you, and once completed, you can submit your work to me for feedback. Coding exercises. Create a model using Keras Sequential API. Learn how to quickly build models using the Sequential API in Keras. Use the Keras Functional API for complex models. Understand how to utilize the Functional API for creating complex models with shared layers or multiple inputs/outputs. Compile and train the Keras model. Practice compiling and training your Keras models, including setting up loss functions and optimizers. Implement callbacks, example early stopping, checkpoints. Discover how to enhance your training process by implementing callbacks such as early stopping and model checkpoints. Evaluate and fine-tune the Keras model. Learn to evaluate the performance of your models and fine-tune them for better results. Save and load Keras models. Gain the skills to save your trained models and load them for future use or deployment. You can watch the accompanying video where I explain these coding exercises, including their solutions, the algorithms used, and the skills required to complete them. After completing this section, you will be able to confidently use the Keras API with TensorFlow to build and train deep learning models. Implement both sequential and functional APIs for various model architectures. Utilize callbacks to optimize the training process. Evaluate, fine-tune, save, and load models effectively using Keras. If you have any questions, confusion, or encounter any problems, please don't hesitate to message me. I'm here to help you succeed. Section 02. Problem 01. Problem statement. Define various types of tensors in TensorFlow and explore their properties, such as shape, type, and dimensions. Skills required: basic TensorFlow knowledge and understanding of tensor properties. Instructions. Define different tensors. Explore and print their properties. Algorithm. Import TensorFlow. Define tensors with different shapes and data types. Print properties like shape, type, and dimensions. How code is working: the code defines tensors of various shapes and data types. Tensor properties like shape and type are retrieved and printed using TensorFlow sessions. This demonstrates how to handle and inspect tensors in TensorFlow. Problem 02. Problem statement. Create TensorFlow variables, assign initial values to them, and explore their properties. Skills required: basic TensorFlow programming and understanding of variables. Instructions. Create TensorFlow variables. Assign values and initialize them. Print their values. Algorithm. Import TensorFlow. Define variables with initial values. Initialize variables. Print variable values. How code is working: variables are created and initialized using tf.variable. The initialization is done with tf.global_variables_initializer, and values are printed using TensorFlow sessions. This demonstrates how to work with variables in TensorFlow. Problem 03. Problem statement. Create a computational graph with multiple operations in TensorFlow and visualize the connections between them. Skills required: understanding of TensorFlow's computational graph and basic operations. Instructions. Define multiple operations in a computational graph. Execute and print results. Algorithm. Import TensorFlow. Define multiple operations, example addition, multiplication. Create a session and run the operations. Print the results. How code is working: the code builds a computational graph with addition and multiplication operations. By running the session, the operations are executed, and results are printed. This demonstrates TensorFlow's capability to handle complex computations. Problem 04. Problem statement. Execute a defined computational graph in TensorFlow and retrieve results. Skills required: basic TensorFlow programming and understanding of sessions. Instructions. Define a computational graph. Execute the graph in a TensorFlow session. Print the results. Algorithm. Import TensorFlow. Define a computation graph. Create and run a session. Print the results. How code is working: the code defines a simple computation, addition of two constants, and runs it within a TensorFlow session. The result of the computation is printed, demonstrating how to execute and retrieve results from a computation graph. Problem 05. Problem statement. Use TensorFlow placeholders to feed data into a computation graph and perform operations. Skills required: understanding of TensorFlow placeholders and data feeding. Instructions. Define placeholders in the computation graph. Feed data into the graph during execution. Algorithm. Import TensorFlow. Define placeholders and operations. Feed data using feed_dict during session run. Print the results. How code is working: placeholders are defined to accept input data during session execution. Data is fed into the graph using feed_dict, and the computation result is retrieved and printed. This demonstrates how to dynamically feed data into TensorFlow computations. Problem 06. Problem statement. Save a TensorFlow model to disk and restore it for later use. Skills required: understanding of TensorFlow's model saving and restoring mechanisms. Instructions. Define and train a model. Save the model to a file. Restore the model from the file. Algorithm. Import TensorFlow. Define and train a model. Save the model using saver.save. Restore the model using saver.restore. How code is working: the code defines a simple linear model, trains it, and saves it to disk using saver.save. To restore the model, saver.restore is used. This process demonstrates how to persist and reload trained models for future use. Section 10. Welcome to our new course, Python TensorFlow Programming with Coding Exercises. In this section, you will learn about deploying TensorFlow models. This section is crucial as it will guide you through the process of taking your trained TensorFlow models from development to production. Here's what you can expect to learn. Article. The section begins with an article discussing deploying TensorFlow models. This article covers the fundamental concepts and provides practical examples to help you understand the deployment process. If you have any questions or need clarification on any part of the article, please feel free to message me directly. Assignment. Topic: Deploy a model to production. Details. This assignment will walk you through the steps to deploy a TensorFlow model to a production environment. The assignment includes comprehensive instructions on how to execute the deployment, along with solution hints. After completing the assignment, you can submit your work to me for feedback. Coding exercises. Export a trained TensorFlow model. Learn how to properly export your trained model for deployment. Set up TensorFlow serving for model deployment. Discover how to set up TensorFlow serving to deploy your model efficiently. Deploy the model as a REST API. Implement your model as a REST API, making it accessible for real-world applications. Optimize the model for mobile using TensorFlow Lite. Understand how to optimize your model for mobile devices using TensorFlow Lite. Test the deployed model on different platforms. Gain hands-on experience testing your deployed model across various platforms to ensure its robustness. Monitor model performance in production. Learn techniques for monitoring your model's performance in a live environment to ensure it meets the desired standards. You can watch the accompanying video where I explain these coding exercises, including their solutions, the algorithms used, and the skills required to complete them. After completing this section, you will be able to export and deploy TensorFlow models in a production environment. Set up TensorFlow serving and deploy models as REST APIs. Optimize models for mobile deployment using TensorFlow Lite. Test models on different platforms and monitor their performance in production. If you have any questions, confusion, or encounter any problems, please don't hesitate to message me. I'm here to help you succeed. Section 01. Problem 01. Problem statement. Set up TensorFlow in your local development environment. Skills required. Basic package management skills with pip or conda. Instructions. Choose a package manager, pip or conda. Execute the installation command in your command line interface. Algorithm. Open command line interface. Run installation command. How code is working: these commands download TensorFlow from the package repositories and install it in your environment. Pip install TensorFlow fetches the latest version from PyPI, while conda install C conda-forge TensorFlow installs it from the conda-forge channel. Problem 02. Problem statement. Verify TensorFlow installation by importing it and checking its version. Skills required: basic Python programming and familiarity with Python libraries. Instructions. Write a Python script to import TensorFlow. Print the TensorFlow version to verify the installation. Algorithm. Import TensorFlow. Print TensorFlow version. How code is working: the code imports TensorFlow and prints its version. This confirms that TensorFlow is installed correctly and allows you to see the installed version. Problem 03. Problem statement. Create and execute a basic TensorFlow session to understand TensorFlow's computation management. Skills required: understanding of TensorFlow's session management. Instructions. Define a computation graph. Run the computation in a TensorFlow session. Algorithm. Define computation graph. Create and run session. Print results. How code is working. The code defines a simple computation, addition of two constants, and runs it in a TensorFlow session. The result is computed and printed, showing how TensorFlow executes operations in its computation graph. Problem 04. Problem statement. Define and initialize constants and variables in TensorFlow and understand their roles. Skills required: basic TensorFlow programming and understanding of data structures. Instructions. Define constants and variables. Initialize and print their values. Algorithm. Define constant and variable. Initialize variable. Print values. How code is working. The code defines a constant and a variable, initializes the variable, and prints their values. Constants hold fixed values, while variables are intended to be updated. Initialization is required for variables to set their initial state. Problem 05. Problem statement. Use TensorFlow to perform basic mathematical operations such as addition, subtraction, multiplication, and division. Skills required: basic understanding of TensorFlow operations and arithmetic. Instructions. Define mathematical operations. Run and print results. Algorithm. Define operations. Create and run session. Print results. How code is working. The code defines basic arithmetic operations using TensorFlow functions and executes them within a session. The results of addition, subtraction, multiplication, and division are computed and printed. Problem 06. Problem statement. Perform basic matrix operations such as addition, subtraction, and multiplication using TensorFlow. Skills required: understanding of matrix operations and TensorFlow's matrix manipulation functions. Instructions. Create matrices. Perform matrix operations and print results. Algorithm. Define matrices. Perform matrix operations. Create and run session. Print results. How code is working. Matrices are defined as TensorFlow constants, and basic matrix operations, addition, subtraction, multiplication, are performed. The results of these operations are computed and printed using TensorFlow sessions.